Okay, implicit differentiation. So we've got here a curve with this equation, right? So obviously it's an implicit equation. And we're asked in part A to find the gradient. So remember the gradient now is the sort of slope of the curve. So we need to differentiate. We need to find dy dx. So we differentiate implicitly. And you look here and you can see there's a product term here, 3xy. So let's differentiate that to start with. So u is the first function there, which would be 3x times v then, which is y. So these two are times together, aren't they? So if you find du dx there, which remember we can write as u dash, that's just 3, and then dv dx, which you can write as v dash. Now differentiate y, you just get 1, but remember then you've got to times it by dy by dx. Okay? So then using the product rule, okay, now the product rule says v du dx, so v u dash plus u dv dx, which is v dash. So this times this, y times 3 plus 3x times this, which is just dy dx, isn't it? Because 1 times dy dx is dy dx. So there is the derivative there of this. So we can use that now when we differentiate this whole equation here. So differentiate it with respect to x. So x squared just becomes 2x, doesn't it? Differentiate this, well I've done it here, so that's plus 3y plus 3x dy dx. Then you've got to differentiate y squared, well that becomes 2y, yeah, but remember you've got to put a dy dx on the end because it's a y term. Differentiate the other side down, so x becomes 1, 3y becomes 3 dy dx, okay, because 3y just becomes 3, doesn't it? But remember to put it times it by dy dx, and 2 then just becomes 0 when you differentiate it. Okay, so group the dy dx's together and factorize. So on the left hand side I've got 3x here, I've got 2y there, and of course if I bring that 3 over it becomes minus 3. On the right hand side then I've got 1, and you take those other two terms over, so minus 2x minus 3y. Okay, so then I got an expression then for dy dx, 1 minus 2x minus 3y all over 3x plus 2y minus 3. So there's my gradient function, and in part A then they're asking for the gradient at the point 2, 0. So at the point 2, 0, dy dx can be worked out just by subbing in 2 for x and 0 for y. Okay, so if I substitute that in there, it comes out to be, well if you work that out on your calculator, I just get negative 1. Okay, so the gradient is negative 1 because that's the value of dy dx. Now you need to think for a minute what gradient, what does it actually mean, yeah? So if I was to draw the curve, okay, the curve might look something like this, okay? At that particular point then, say there's my coordinate there, what was the coordinate? 2, 0. Well, the gradient is measuring the slope of it, isn't it? So remember, you've got the slope of it there, and you can draw a tangent, can't you? So what I've actually worked out at that particular point, the slope there, I've worked out the gradient of the tangent. So my dy dx value, or my gradient here, is the gradient of the tangent, okay, which is negative 1. That's going to help me with B, because in B it says find the equation of the tangent at that point. So we need to find the equation of this tangent that I've drawn here. Now, if you recall the equation formula, okay, that we learnt in AS is y minus y1 mx minus x1, yeah? Okay, and for the equation formula you need the gradient, which is m, okay, and you need a point. So our point is going to be of course 2, 0, and I've got my gradient there, so you put that in. So my y1 is 0, gradient is minus 1, my x1 is 2, and this becomes really easy then because you just got y here and multiply through by negative 1, so I've got minus x, and negative 1 times negative 2 is plus 2. So there's my equation of the tangent. Okay, now in C they want the equation of the normal, if you remember the normal, so if I draw that sketch again, okay, here's my tangent, yeah, at that particular point, at the point 2, 0. But remember the normal is perpendicular. That's the normal, yeah? It's perpendicular to the tangent. Okay, so I've got the line going this way at right angles to my tangent at that point. Now if we know the gradient for this is -1, okay, remember what we did last year, we call it, say, m1, it's -1, and then the gradient of the normal would be m2, and then we'd use this formula, m1 times m2 is -1. Remember that is always true when two lines are perpendicular to each other, when they right angles to each other, this formula works. When you times the gradients, you get -1, okay? And we know the normal is always perpendicular to the tangent. So you've got your tangent gradient here, which we worked out, so sub that in, -1 times m2, and that equals to -1. And if you remember, what you do then is you take this value over to the side and you divide, yeah, because you're timesing here. And of course this becomes easy then, because -1 divided by -1 is just 1. So the gradient of the normal is equal to 1. Okay, now to determine then the equation of the normal, well, we use the same equation formula that I wrote down earlier on, okay, which is y minus y1 mx minus x1, using this gradient this time, and of course the same point 2, 0, so y minus 0, gradient is 1, x minus 2. So you get y equals, well, of course this time it's just times by 1, so it stays the same. So there is my equation of the normal, y equals x minus 2.